All right, class. Today, the board work posed is how does a battery relate to a water pump? Look up, class, at the board. How does a battery relate to a water pump? Any suggestions?
The flow of electricity?
Okay, very good. I have put some examples of what a water pump does. It takes in water at a low pressure, does work on it, and it ejects at a high pressure. The relation comes because a battery takes in charge at low voltage, does work on it, and ejects it at a high pressure. In case you don't know, today's topic will be on voltage. What we will cover in voltage today is the definition, voltage examples, electromotive force, potential difference, and voltages versus voltage. I have some expectations for you guys as a class, and these expectations are being able to identify voltage roles, examine a circuit and determine voltages in it using a multimeter, express voltages in joules per coulomb, and distinguish between voltages and voltage. All right, class, what do you think the voltage in a AA battery is? Marcus, you look intrigued. Can you help me out?
Sure. 1 volt.
1 volt? Well, I have a multimeter right here, and I'm going to take the reading. I have 1.5 volts. Does that make sense to you guys?
Absolutely.
Yes.
All right. So,
I think it even says how much is on it. Right on the battery,
correct.
right?
Correct. But the multimeter just confirms it, you know. We're going to move on to the definition. So voltage is electric potential per unit charge. So that battery, when I loaded up on the multimeter, read 1.5 volts. So it would be actually 1.5 joules per coulomb, but it's also equal to voltage in our simple terms.
So it would actually tell us how charged the battery is then.
Correct.
So you could test this battery and tell me how much voltage is in that
Correct.
compared to that
Thank
brand
you.
new one.
Oops. .5.
Pretty dead.
Almost dead. All right, gang. Next, we're going to move on to voltage applications. Voltage is critical in Ohm's law. It helps find current, which we discussed yesterday, and it helps us understand conservation of energy around a circuit. This is Mr. Ohm here. This is his law in these 4 corners. And voltage is equal to E, current is equal to I, resistance is equal to R. Current is E over R, resistance is E over I, and voltage is I times R. Conservation of energy is also a voltage application. What was the other voltage application, Marcus?
What?
What was the other voltage application?
Not sure.
Okay, we'll
I
go
was
back.
grading you.
It was Ohm's law. Okay, now we're going to move on to the second application. Second application is conservation of energy, and that states that voltage drop must sum to 0. And it's saying that energy is neither created nor destroyed. So as this moves around, the voltage has got to add up to 0. All right, guys. For our second demonstration today, I have 2 Pepsi bottles. One is going to represent EMF. The other is going to represent potential difference. Does anyone have any clue what any of these words mean? Mr. Curran.
I think EMF is electromotive force.
Okay, do you know what it means?
It's the I think I would have a hard time to explain it. Would you be able to tell me?
Yes, I will tell you in a sec, just after this explanation and this demonstration. Well guys, EMF and potential difference are two different things, and they will be covered today.